Hello YouTube, I'm your friendly robot voice guy, teaching you how to do prime factorization. I'm actually not a robot, I'm actually a teacher. So the voice you're hearing, I'm standing in front of 27 of my brightest pupils that I have 7th period. You're welcome. We're going to be doing prime factorization. You guys had this last year. That's why it's going to be very efficient. Yes, you had this last year. We're going to continue with it right now. If your name isn't on it already, please make so. Hello. A prime number is a whole number greater than 1 that is exactly 2 factors, 1 and itself. All right, that's a composite number. A composite is a whole number greater than 1 that is more than 2 factors, okay? That is numbers that are not on your yellow sheet. That yellow sheet is your friend. That yellow sheet is going to help you prepare for this test. That yellow sheet, when it's out, when you're doing your homework, is going to make it go so much more fast. So much faster. So, you should have written down 2, 3, 5, 7, 9, 13, 17. There's no 9, you silly, silly guy. 11, 19, 23, Michael Jordan, and 29. Sweet. What? No, look. You have a yellow sheet of paper in it, so I told you to write down. Yes, I did turn it back on. Yes, thank you. Good looking out. Look on your... This is what I was talking about. That's been my day. I need you to be with it at practice because we need to teach all those boys how to play volleyball. We have a game in 4 practices. All right. Starting off with 3 different factor pairs. We see which works best. Factor pairs. It's like Georgia peaches, but factor pairs. We're going to start with 2 here and 12 here. Whenever we have a factor tree, every line horizontally, when you multiply those numbers together, you're going to get the number at the top of the factor tree. Because 2 times 12 is 24. 2 is a prime number, so I'm just going to bring that down this tree, down that branch. Then we have 2 times 6, which is 12. So if I were to go 2 times 2 is 4, 4 times 6 is 12. See how each line is true? Yes? Yes. So then I have 2. Then I'm going to have 3. Then I'm going to have 2. Because you guys did this last year. Now it says rewrite in order. 2 times 2 times 2 times 3. All those numbers are prime. Yippee! We got it. We're done with that one. But that's not the only way that you can do it. There's other ways you can climb a tree. Because it's the tree method. Okay. Let's try 3 by 8. Oh, I'm a teacher. I'm supposed to say those lame jokes. So then I'm going to break down where 8 is, or 2 is. Whoa, 8, which is 2 multiplied by 4. That's prime, so keep going. Doom, doom, doom. Rewrite them in order. Same thing as what's next to it, as it should be. 23. But you guys are young, hip, and cool. Now, look how this one has so much less work. It has, 33% of the work? No, it's 33% off. What we're going to do is, see how there's a whole less level? Look how many less numbers we're going to write with this one. Right? So, I'm going to do, on this one, a bigger factor. And I rewrite it. It's already in that order, but I'm going to rewrite it anyway because that's the instructions tell me. And I follow directions so I don't get things marked off. Yeah. Lead by example. Now, for the second one that we have there, it says, I'm not going to move it off the screen. Why did the third try work faster? It's because we use larger factors. We used composite factors. Used composite factors. Sorry. We use composite factors. Method 2 for factorization, prime factorization. Box method. In the book it's called cake method. Last year we probably called it the was it the cake? It was not cake. Oh, step or ladder method. You guys remember the ladder method? Okay, I guess we'll see which class decides to do it, but it's going to be called the same thing from here on out. We'll see if it's going to be box or ladder. Okay. So zooming in here, find the prime factorization. Of 36. So in your book, it's called the cake method, and it goes upside down from where it is. So that's why it might look different if you actually look at your book. 36. The prime factorization of 36. Try starting off with different factor pairs. Someone give me a factor of 36. 6? Okay. You want to do 6? What do you think about, let's try 3, yeah? Or no, 3, because 3 plus 6 is 9, and we know that it's going to be divisible by 3. We're just going to go with that. You will use 6 in example, the third example of this one. Deal? Okay. Did I say 2 or 3? 3. 3. That's 12. The way that I'm getting that 12 is 36 divided by 3 is 12. Now I'm going to take one out of here, 2, and I'm going to get 6. I'm going to take 3, and I get 2 left over. Then I'm going to take the stuff on the outside, and I'm going to multiply them together. Okay, yes, this. We got in order. I've got 2 times 2 times 3 times 3. 2 times 2 times 3 times 3. 2 times 2 is 4 times 3 is 12 times 3 is 36. How about a different way of doing it? I'm going to start with the 2 this time. And 2 divided by 36 is going to be 19? No. 18. Thank you. I heard 19 and lost my train of thought. Here we go. 2 again. Here's 3. There's 3. Same thing. 2 times 2 times 3 times 3. Now, we're going to use 6. We're going to use 6. And 6 divided by 6 is that. Then, wait, we're not done yet, though. We're going to go 3 and 2. Now we put them in order. There. Doom, 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 doom. Why doesn't it work? Wait a second.
It does work.
But it worked. It worked right there. Look, if we did 6 times 2, because 2 times 3 times 6, that is 36. It worked. Then why does it say it didn't work? Everybody say that one word as to why you think it isn't. It's not prime. This section is prime factorization. 6 is not prime. 9 is not prime. It needs to be prime. Because it's not the optimal situation if it's not prime, and it's not optimus prime if it's 4.4 prime factorization. Why third try not work? Because 6 isn't prime. All right, here we go. Factoring negative monomials and monomials with variables. Use the method that you like best. Isn't it wonderful when you learn 2 ways of doing things and in the instructions they're like, hey, you can use whatever you want. You're like, thanks, man. Do you agree that negative 1 times 18 is negative 18? Okay, before you argue with yourselves, how many negatives are in that, Mandy? Only one negative. And when you have signs that are different, what's the product? Negative. So negative 1 times 18 is negative 18. So you have to pull this negative 1 out before you even continue. Then you do the prime factorization. And that's your answer. You got to get that out of there for it to hold true, because prime factorization, when you multiply them all together, you're supposed to have the final product, which is negative 18. Now, we're combining what we did on Friday with this class. First thing that I want you to do whenever you see variables in there, kick them out. It's like when you guys don't have your homework and you get kicked out for a little bit. Okay? To do your homework or so you don't get the answers to the stuff. So I'm going to kick those guys out. I'm going to now do the prime factorization of here. Wait, can I do this? Yes, I can, because it's not the box method. You just can't do that in the box method. Because I found my prime, which is the age of 32. Oh! Self-confidence. That's right. All right. So, yikes. 2, 3, 7. And I have to now bring these guys back in the room because we're done checking our homework. And there are 3 X's and 2 Y's. Now that's how you get the answer to that one. X cubed y squared. 42 x cubed y squared. Now we did the let's do the box method on this one. Yes, sir.
When you're writing them out, can you instead of writing out x times x times x, you do x cubed?
No, because that's the opposite of what we're trying to do. We're trying to get that be prime factorization where everything multiplied together at the end is going to give you that. We're not using exponential form. Okay? So we kicked x to the fourth out. I'm going to use the box method. Please stop tapping or clicking your pen, whatever it is. I'm going to pull out -1. Salud. There's 38. What's a prime number that goes into 38? 3 plus 8 is what? 11. Is that divisible by 3? No. Okay, so we can't make it bigger, so I have to go smaller. 2. $19. So I have, and 19 is prime, so I'm done there. -1 times 2 times 19. Please stop breathing through your pen cap. 4. And that's the answer to that one. And here's what you guys get to do. No. You are going to try these 3 on your own. I'm going to give you a couple of seconds. Shh. I'm going to give you a couple of seconds to get started, and then I'm going to do them on the board so you can see if you've gone the right way. Let's do tree here and boxes over here. And then on the homework, you'll be able to choose whatever you want. So do that. Tree on number 4, boxes on the other 2. Go ahead. Yes? Okay. So make sure you finish that tonight or something. And you're baseball as well, correct? No, you're not. Isn't there a third?
Yeah, Brayden. Garrett's gone now.
That's it. Okay, we are not talkings. You're checking to see if you did these right. You're not talking. Question?
Which one do you need the box on?
The other 2. Win, win, win. Ooh, yeah, definitely. Take Liberty down. I'll back out in a minute. The end.